This video, we're going to be talking about a new theorem called CPCTC. Now, it's a lot of letters, but it's important to know what each of these letters represents because it is a huge, huge concept in geometry. After we prove that two triangles are congruent, we can use this theorem to help us make some other conclusions. So, a way to help you remember this is Cool People Complete Task Cards. So again, that's CPCTC. Now, what it stands for is corresponding parts of congruent triangles are congruent. Now, that is a mouthful, but what it means is that once we prove that two triangles are congruent, now remember, the way that we prove that two triangles are congruent are by the 5 theorems. So, side, 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 angle, side, angle, side, angle, 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 side, and then HL. Those are the 5 triangle congruence theorems that we can use in proofs. And once we know that two triangles are congruent, we can go ahead and make conclusions and say that all of the corresponding pieces are congruent as well. Now, the reason that this is important is because let's say, for example, let's say you've proved a triangle to be, or two triangles to be congruent using side, 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 right? What you know right now only is that all 3 pairs of sides are congruent to one another, but we can use CPCTC to help us make conclusions about the 3 angles that are in there as well. Now, for side, angle, side, I'll draw this image a little bit bigger for us. So for side, angle, side, the conclusions that you should have might look something like this, what we're drawing in red, right? For side, angle, side, you only have that information, right? But we can use side, angle, side. We conclude that these triangles are congruent, right? And then CPCTC says, hey, all of the other corresponding pieces, since we know our triangles are congruent, all of the other corresponding pieces have to be congruent as well. Now, what that means is, hey, this top angle here must be congruent to that top angle here, and that's because of CPCTC, because we already know that the two triangles are congruent, right? Last, or not last but not least, but next, okay, I have these 2 angles. I don't know any information yet, but since I know those 2 triangles are congruent and those 2 angles are corresponding, using CPCTC, I can say that those 2 angles are congruent as well. Now, last but not least, we don't have any information about this side here. However, we know that our 2 triangles are congruent. Therefore, this side and this side must be congruent to one another because they are corresponding. Remember, corresponding just means that we're in the same position. Now, there are some tricks that we're going to go over in this video that are going to help us, because when triangles are drawn like this, it's easy to see the pieces that are in the same position as one another. But in more complex examples, we're going to teach you guys some tips and tricks on how to identify the corresponding pieces. So again, with CPCTC, you first need to prove that your triangles are congruent, and then you can make some other conclusions about all of the other corresponding sides and angles. All right, so these are some type of questions that you guys might see. So we're going to practice drawing the triangles in the same orientation, right, so that we can see the corresponding pieces. And in this case, I'm going to teach you guys the letter trick. So it says, in the diagram below, triangle ABC is congruent to triangle XYZ, and it says which statement must be true. So all of these answer choices are trying to get us to see, hey, which angles, like if there are corresponding angles in an answer choice, then you should know that those angles are congruent using CPCTC, right? Because we already know from this piece, I know our triangles are congruent. Now I want to see, hey, I know that they're congruent. All of the corresponding pieces must also be congruent. So our first battle is to draw these triangles in the same orientation so that we can easily see which sides and which angles go together. Now the letter trick, lets you use the orders of the letters that the triangle is named, right? So in triangle ABC, A comes first, and then in XYZ, X comes first. So the first thing, before I even do that, I'm just going to actually draw, one of the triangles in the orientation that it's already in. So this, I'm going to just draw triangle ABC. Now I'm going to have to flip around triangle XYZ in order to match it up. So before I even put any letters, I'm just going to draw another triangle that's in the same orientation as ABC, and we'll worry about the letters after. So again, X comes first here and A comes first here, so I know that those go together since they both come first in the name, right? So A is in the bottom left, so I know X is going to be in the bottom left as well. Then we have Y and B in that both come second. So I know B and Y are corresponding, which means they have to go in the same location. So this letter here should be Y in the bottom right. And then I know last but not least, we have that Z comes last and C comes last. So I know that C and Z are corresponding, which means that they must be in the same general position. Now, I know again that these two triangles are congruent, right? So now that I have all of the corresponding sides and angles kind of matched up, I can make a lot of conclusions, right? For example, I know that angle A is going to be congruent to angle X, right? Because of CPCTC. I know angle B is going to be congruent to Y because of CPCTC. And I know that C is going to be congruent to Z because of CPCTC, right? So maybe we just want to write that out. I know angle A is congruent to angle X because of CPCTC. I know B is congruent to angle Y, and I know angle C is congruent to angle Z, right? And again, it's because I already know my triangles are congruent, and these are all pairs of corresponding angles, so I know those must be congruent as well. Now, this also goes for sides. So, for example, side AC corresponds to side XZ. So since they're corresponding and I know the triangles are congruent, I can go ahead and make that conclusion that these sides are congruent as well, right? And we should label our angles as well. So A and X, B and Y, and then C and Z. And then we have AC and XZ. We also have BC and ZY are corresponding. Therefore, we know that they are congruent using CPCTC. And last but not least, we have AB and XY are congruent because of CPCTC. Now, to identify your corresponding sides, you can also use the letter trick. For example, it's going to be a little different though. You're going to have to look at pairs of letters. So for example, we have AB here coming, right? So we know AB corresponds to XY. We will also know that YZ corresponds to BC. And then last but not least, the first and the third letters, right? So we will have XZ corresponding to AC. So if you don't want to use the letter trick for the sides, that's okay. Once you draw your triangles in the same position, you should be able to see it. But again, you guys can pick and choose the methods that you like to use. So let's go through the answer choices. So this says that angle C is congruent to angle Y. Well, if you look, this is why drawing your pictures is so important, because if you look at your pictures, we can see that angle C, which is here, and angle Y, which is here, those are not in the same general position, right? Those are not corresponding angles. So we can't conclude that from CPCTC. So we don't know that that must be true. We don't have enough info about that. Like, we can't make that conclusion. Angle A is congruent to angle X. Well, if you look, those are in the same general position, right? We know our triangles are congruent, therefore our corresponding angles, which A and X are corresponding, those must be congruent. And we've already labeled that, right? So I know that this is an answer choice, but let's just go through the others to make sure those aren't true. So AC and XZ, AC and YZ, right? So AC and YZ, those are not corresponding pieces, so we cannot conclude that they are congruent. And last but not least, let's do this in a different color. Let's pick this yellowish orange, CB and XZ. CB is here and XZ is here. Those are not corresponding pieces, right? But it might be hard. Like, if you didn't redraw these, you would see CB and XZ, and like, just by looking at that quickly, I can't really tell that those aren't corresponding pieces. That's why you need to draw your pictures like this, okay? All right, another example here. So I'm not going to go as in depth with this one. We're just going to kind of move through the logic, and if you're confused by it, just rewatch that last portion. So it says in the diagram, AEC is congruent to triangle BED. Which statement is not always true? Ooh, be careful in there. When you have a not, you want to make sure you are very mindful. So my first step again, I'm going to pick a triangle, and I'm just going to draw it in the position it's already in. So I'm going to take triangle AEC, and I'm not going to move that around. And then I'm just going to draw another triangle that looks like the one I just drew, and I will worry about labeling it after I use my letter trick. So I see A and B come first, so A and B should be in the same position, which we have in the top. Then we have E and E, the same letter, yeah, but those should go in the same position as well, right? So in that bottom right. And then lastly, we have C and D coming last, so I know D has to come in the same position as C, which is in the bottom left. Okay, now let's go through our statement. So again, we know already that our triangles are congruent, right? We know that. So we can use CPCTC to say, hey, I know all of the corresponding angles and all of the corresponding sides must be congruent as well. So let's go through these choices. So choice number 1, Let's do this in purple. So choice number 1 says that AC is congruent to BD, right? So AC is here and BD is here. Those are corresponding pieces. So we can say using CPCTC that they are congruent, right? So this is a not question. So this is true. So we cross it out. Choice number 2, let's do in this blue color. So it says CE is congruent to DE. So again, you can see that those are corresponding pieces. They are in the same general position in the triangle. So that is true. So we're going to cross that out. In green, let's do this one. So it says angle EAC, which is here, is congruent to EBD, which is here. Right? And again, you can see that those are in the same general position in the top of that triangle. So that is true. So we're going to cross that out. Last but not least, we have in this light blue color, angle ACE, which is here. It says it's congruent to angle DBE, which is here. Right? Now you can clearly see those blue angles are not in the same general position, right? So we cannot use CPCTC to say that they are congruent. So this statement here is not always true. All right, one more example like this. So it says the diagram below shows a pair of congruent triangles, right? Which statement must be true? So again, I'm starting just by redrawing one of the triangles in the orientation it's already in. So I'm going to take triangle ABD, and I'm going to carry my labels over. And then, so this is a little bit different, right? So in this case, we don't have letters given to us, like it doesn't state the names of the triangles. So we have to use a slightly different method here. So in this method, we're going to try to line up the congruent angles, right? So I'm still going to redraw a triangle that looks like the one I'm drawing. But instead of putting my letters, I'm going to put the angles, the congruent angles in the same spot. So for example, I'm going to put my double arced angle in this right corner, this upper right corner, I guess. And I know that that is our angle B in the second triangle. And then I have my single arc here, and that is again letter D. And then in the top, I only have one angle left, right? And that is angle C. So there might be times where you're not given, like this triangle doesn't specifically name the triangle for you, right? It doesn't say, hey, triangle ABD is congruent to triangle CBD, right? It doesn't say that, so we can't use the letter trick here. So we got to kind of try to align the congruent pieces. Now, if we had congruent sides instead, we would use the same logic. But we do know that they are congruent, right? So we know using CPCTC that the corresponding parts must be congruent. So let's just go through our answer choices in some colors. So the first one says angle ADB, which is this one right here, is congruent to CBD, which is this one right here, right? And we can clearly see those are not congruent pieces or not corresponding pieces, so that cannot be true. Next one, let's do in this greenish color. It says that ABC, which to be honest, we don't even have that. ABC is this angle right here, and the whole entire of combining those two triangles together is congruent to ADC, which is here. So there might be times where you have to go back to your original picture. Now in this case, it wouldn't be true. And if you assign number values to these angles, right? Like if you gave this angle 30 and 30, that whole angle would be 60. But since this has a single arc, we know that can't be 30. So let's say this was like 20 and 20, right? Clearly those two larger angles are not congruent. AB is congruent to CD, right? So AB is here and CD is here. Those are not corresponding pieces, so we cannot use CPCTC to say they're congruent. And last but not least, hopefully this one's true. If it is not, then we've made a mistake somewhere. We have that AD is congruent to CD. Now here you can see those are corresponding pieces, so we can use CPCTC to say that they are congruent. Now, I know this is a long video, but it is such a huge concept, and I'm going to show you guys how to use it in proofs now. So proofs involving CPCTC will not tell you to first prove that the triangles are congruent, but you need to do it. Remember, in all of these other examples that we had two congruent triangles, right? Without having two congruent triangles, you cannot use CPCTC. So I like to work backwards. So right now, it's telling me to prove that BC, which is here, is congruent to BD. So in this diagram, it's not super complex. Like I can see there are only two triangles. So my initial game plan, I know I'm going to need to prove the two triangles to be congruent, right? I know that. And I know it's going to be triangle ADB and triangle ACB, right? But be careful. When I'm telling you the letters, if I'm saying ADB and ACB, I don't know. I can't use the letter trick there. But if the question rates it for you, you'll always be able to do that. So let's just go through our proof let's just start with our basic steps. But again, remember, we work backwards. So I looked at my proof statement. I identified, right, BC and BD. Those are going to be the corresponding parts of the separate triangles, right? And now it might help. We're going to go ahead and draw these in the same orientation. So we have A, D, B. Now we can't use the letter trick here, but we got to kind of just imagine, right? Like imagine the pieces that would match up. And you can see that A is a part of both of the triangles and B is a part of both of the triangles. So those are going to go with each other here. And then the only other letter we have is C, right? And you can kind of imagine if we flip this triangle upwards, it would kind of land directly on ADB, which is what we would want. So I'm going to clear this and just redraw my triangles real quick, just so that I have a clear thing when we want to label our stuff. So we have ADB, ABC, and we're going to do our statement and reason. Let's write our given. So we have angle DAB is congruent to angle CAB, and then we have angle D is congruent to angle C, given, and let's make sure we label those. So DAB is right here, is congruent to CAB, which is right here, and I'm going to label them on my separate triangles too. DAB is congruent to CAB, and then we have angle D is congruent to angle C, and I'm going to go ahead and label that as well. Okay, awesome. So now also what I'm noticing is that my two triangles are sharing a side, right? And when they share a side, we have to put that X in our diagram here, and we can also put that here, and we can put that here. And I know I'm using the reflexive property there. So there I'm going to say AB is congruent to AB, and that is reflexive property. Okay, and now once I label, I just want to like go back and analyze, like, do I have enough to prove that my triangles are congruent yet? Because I know I need to do that first, right? Because again, what we're trying to prove, and sometimes drawing these triangles in the same orientation will help you with this, we're trying to prove that BC is congruent to BD, right? The first thing that's standing out to me, those are in the same position, they're corresponding. So I want to use CPCTC, but I cannot do that unless I know the triangles are congruent, right? So you have to remember, we got to make use of our 5 triangle congruence theorems, which I wrote down on the other slide. But right here, what I'm seeing is that we can use angle, angle, side, because we have 2 angles in both triangles, right? And the non-included side, that tells me I can use angle, angle, side to say, hey, triangle ADB is congruent to triangle ACB. And again, the reason I'm doing that, I have to name the theorem. We're saying that, hey, the 2 angles and non-included side of one triangle are congruent to the 2 angles and non-included side of another. And once we have this, right, after you prove that 2 triangles are congruent, right after is going to come CPCTC, right? There's nothing really else that can come after that. It's always going to be CPCTC. So think about like peanut butter and jelly or Mario and Luigi, right? Once you prove 2 triangles are congruent, CPCTC comes right after. And what we're using CPCTC to say is, again, remember, corresponding parts of congruent triangles are congruent. Now we're saying, or we can say, that BC is congruent to BD. And you don't have to write the whole thing out. It's actually okay on the Regents to write it like this, right? CPCTC, that is a universally understood theorem. And you want to make sure that you know what that stands for. You need to understand when to use it, right? And in a proof, you have to be able to take this proof statement and be able to identify that you first need to prove the triangles are congruent, because the proof will not tell you that. You have to be able to look at your proof statement, analyze it in your separated diagram, right? And then figure out that you need to prove the 2 triangles congruent first. All right, awesome. Thank you guys for watching.